There are a lot of myths around quantum computing, especially if you're a developer and you work with code on a day to day basis. You've probably heard some things about quantum computers, about what they can do, what they bring, and how they can solve any problem faster than a regular computer. Now, a lot of these myths aren't really true, and they can lead to some bad assumptions that us as developers shouldn't take at face value. What we're going to do in this video is go over some of those myths and figure out what's really true about quantum computers, what it means for us, and how we can use them. Let's get into it. Myth number one is that quantum computers are just faster computers. That's not quite accurate. Now, quantum computers are special in a way that they're a fundamentally different way of taking data and computing values from it, but they're not just faster computers. In a lot of ways, quantum computers could be slower at solving certain problems than a classical computer would be. Quantum computers are highly specialized machines that really excel at solving certain types of problems like logistical problems or cryptography related things. They're not a general use all case for regular computing. Myth number two is probably one you've heard a lot, and it's that quantum computers will instantly break all encryption. The reality is, not all encryption is equally affected. The main concern here is public key crypto like RSA or any elliptic curve based system. Symmetric crypto and other hashes are impacted a little bit differently. Current quantum machines are not breaking modern internet encryption today. We still have a little bit of ways to go before quantum computers are to the point where we really have to worry about them. That doesn't mean that we shouldn't prepare today, though. However, attackers today can still collect encrypted data with the hope that in the future, when they have access to a sufficiently powerful quantum machine, they can decrypt that data and harvest the sensitive information. Myth number three is that quantum computers will replace normal computers. This isn't true. In 50 years from now, when the iPhone 30 comes out, you're not going to be walking around with a quantum chip in your pocket. At least, probably not. They're not going to replace laptops, your phones, or even really many servers. Most real world systems are going to remain classical. Quantum will likely be used as a specialized accelerator for only certain tasks. You can think of hybrid systems, this classical application and quantum backend for specific workloads. Myth number four is one that I like to talk about a lot, and that's quantum computing is just normal programming with a different library. Now, that's far from the truth. The syntax may look familiar because of libraries built by large companies to make it easier to develop with quantum programming, but the mental model is very different. With quantum computing and quantum algorithms, you're working with qubits, gates, measurement, and probabilities. You run a quantum algorithm many, many times over, known as shots, to get a probability distribution of what the answers are, and then from there, you can do a calculation. You can't treat qubits like normal variables. Outcomes are probabilistic, so debugging and reasoning are different too. Now, myth number five is that quantum computing is too far away to matter. This couldn't be further from the truth. The hardware still may be a little immature today, but the migration problem is already real. Crypto changes take years, not weeks to implement. Think about complex systems that you've worked with. It would take a while to migrate those systems onto a different authentication flow. Devs and security teams need to know where public key crypto is used by doing audits of their codebase to figure out what code uses these keys and what third-party vendors might use them under the hood. Long-lived data matters most. Records, signatures, certificates, backups, things like that. If the threat has a long runway, waiting is already a mistake. So all that's great. We've talked about some myths and maybe we know a little bit more about quantum computing, but so what? What do devs and security engineers actually need to know and care about? Well, the thing is, you don't need to panic. You just can't ignore the problem. Just start paying attention to TLS and their certificates, signing systems, identity and authentication, things like that. The real skill right now is crypto agility and being able to plan for post-quantum migrations. Quantum doesn't mean the end of security. It just means that security teams need to prepare a little bit earlier. So to wrap up, some of the key points I really want to stress are that quantum computers are not magic. They're not useless either, even though the machines today aren't exactly as powerful as they need to be to cause issues. It's still something we need to think about and plan for in the future. They're highly specialized machines meant for very specific sets of problems. So they're not generalized, replace everything all at once type of computers. but they will very much increase certain parts of our lives. I'm curious what kind of myths that you hear on your day to day. I know when I talk to my coworkers and friends about technology and things coming in the future, I hear a lot of things that might not necessarily be false, but they're not completely accurate either. So, as always, if you liked what you heard, subscribe, leave a like. It'd mean a lot to me, it would help the channel out. If you want to hear more about quantum topics, maybe drop a comment, let me know what you'd like to talk about, and I can make a video for it. Thanks.